Okay, in this video I'm going to be going over how to use analog inputs and outputs. And we're going to start with a sketch here. I just launched the Arduino interface, and I sometimes will just leave this up here with the setups because it's kind of nice that it's already here. I don't have to recreate it. I can do the same thing with a loop. And I'm going to start with my header. So now you might have also noticed that I've got the line numbers here visible on the left side. And if you do that, I think it's through, let's see, File Preferences. You can have a checkbox here that says Display Line Numbers. And sometimes people will turn that off because it can be a little distracting. But what is convenient is that if there is an error, when it compiles, it'll show a line number. And so you can kind of identify where the error is. So let me go ahead and work through this sketch. And we're going to be using the trainer board. I went over that a little bit last week, and we'll be looking at some specifics for the analog inputs and outputs here. And I'm also going to introduce you to the serial monitor, which is very easy to use. And the cool thing about it is it allows you to visualize or actually see variable numbers on the screen, which otherwise you wouldn't really be able to see them displayed anywhere else. I should probably just type and try not to talk at the same time. It's too hard. So we're going to look at A0, which is connected to what is called VR1, variable resistor 1, A1, which is connected to VR2, and finally A2, which is connected to VR subs LDR, which is the light dependent resistor. Should be kind of fun to play with a little bit. We'll talk about that briefly. Okay, so in the setup, before the setup, we need to do our variable definitions here. We're only going to use one variable, and we'll call it dial. Actually, I'm going to call it analog value because we're going to use it for a few different things. And we don't really need to define it with a number or starting point, and it's certainly not a constant because it's going to change over time. Okay, so in our setup, what we're going to start using is a serial monitor, and that'll allow us to actually see these variables on the screen. And I'll show you how to walk you through how that works. So to do that, in the setup, we need to use a command called serial begin, and we're going to select what's called a baud rate, or a communication rate. And that's all we have to do to get that working. And then in the loop, I'll show you how to actually output values to the serial monitor. Okay, so with the, if you've watched the PowerPoint already, it walks through the commands that we use for reading analog values. And I'm not going to go through the map function in this video. I just want to show you kind of this very simple approach to how we can read these values. Or maybe I will if I've got some time here. So I'm going to set now, one of the things that's interesting, as I mentioned, is that for digital inputs and outputs, you have to use pin mode in setup. But for analog inputs, you do not need to define them. Later, we'll see, though, that for analog or digital outputs that are used for analog outputs, sounds a little confusing, we do have to define them. But we're just going to look at reading these inputs right now. So I'm going to use this analog value. I'm going to read the A0 port. A0. And that's connected to variable resistor, which is abbreviated VR1. And so that reads the value immediately at that point in time into this variable, analog value. and then we're going to print it. And I'm going to use print line, LN, analog value, because otherwise it won't space the text out properly. And we'll talk a lot more about serial printing and using the serial monitor in upcoming lectures. But I just wanted to kind of introduce this to you because it's really very easy to use. You have to initialize it, and then you can output values to the monitor, and you'll see how this works. So I'm going to check and see if I have any errors at all here. No errors. I need to name it to a better name than the date. I'll do that a little bit later. And then we'll start the sketch. And then if you take a look up on the top right corner, there's this little button that says Serial Monitor. And if I click on that, it'll start putting out these values here. And it's reading 0. So what it's doing is it's reading the analog pin A0, and it's outputting it to this serial monitor. Now, what we're going to do also here, I'll see if I can do this. This should work okay. There we go. We can also look at the same time, we're going to look at the Stemterra board with the trainer plugged in. So if you take a look here, the variable resistor 1 is on the left, variable resistor 2 is on the right, and they're marked for A0 and A1. They're already wired to these pins. You don't need to hook up any wires on the breadboard. They're pre-wired in. So what I'm going to do now is adjust this potentiometer here, and you'll see that as I adjust it, the value on the serial monitor starts to increase. And if we crank it all the way to the right, we get a value of 1023. And as the PowerPoint explained, that is basically a power of 2 to the 10th, minus 1. So pretty cool. And this is a nice way to just verify and make sure that the value is being displayed and being read properly. And we'll use this serial monitor more often for debugging programs too. We can look at variable values. There are lots of ways that we can check things. Now, I'm going to change this now so that we're reading analog 1 here, A1 instead of A0. Okay, upload it again. Start the serial monitor. Whoops, wrong thing there. And we'll, let's get the serial monitor back up there. And then I'll run there we go. Okay, so now you'll see, all I've done here is changed analog, we're now reading analog input 1, which is mapped to this potentiometer. So changing this value is not going to change anything at all. But if we change this value, now we're going to see it change and adjust. Okay? Now, the last analog input that we have to work with is analog input 2. That's the only other one that's really mapped to anything on this board for an analog input. And that is connected to what is called a light-dependent resistor, LDR. Now, if I expand this a little bit, I think I can do this here. Let me try this. There we go. It's this kind of funky-looking two-leaded device that has usually these kind of like squiggly lines on it. And what it is really is a semiconductor material, and almost all semiconductors are sensitive to light. What's interesting is LEDs, which we think of as putting out light or outputting light, are also sensitive to light. You can use them as a simple light sensor. But these ones specifically are used for all sorts of things. Traffic, turning on, not traffic lights, but street lights at night. They have really large LDRs in them. Alarm clocks, or anything that has a digital display where the intensity of the light changes if it's dark or light in the room. Light sensors, they used to use these in refrigerators. Nowadays, it's typically a mechanical switch. But there are all sorts of applications. So, and they're pretty easy to use. It's wired to another resistor on the input pin. So it's not wired directly across it, because if you're not careful, you can burn them out. But that's really more of kind of a 130 topic. We're not going to talk about that in too much detail in this class. So now what I'm going to do is I'm going to change this to analog read 2, which is again mapped to that LDR. I'm going to compile it here. Open the serial monitor. And now what I'm going to do is cover this up. And you can see the value dropping and increasing. And if I had a really bright light source, I don't have my phone next to me here, but if I had a really bright light source, it would the number would increase dramatically. So if I block it almost completely here, if I put my finger on it, it'll go down to like 300 or even below that value. So that's a cool sensor. We're going to be using that in the lab this week, and there are all sorts of applications you can use that for. Programmable nightlight, all sorts of things. But I want to kind of walk through a little bit of an introduction with that. And I will take a moment of time here to go through analog outputs. What's important, as I mentioned in the PowerPoint, is that in this case, we're only using pins D3 and D5, which are connected to LEDs 2 and 4 for analog outputs. And let me go through a real simple example here. Okay, so I've added a few lines of code here to show how we can output a value as an analog value. So first of all, I am defining LED2, which if we take a look at our trainer board here, LED2 is mapped to pin D3. Now, the reason I didn't map it to pin 2 is that if you remember, digital inputs 0 and 1 are your TX and RX, and we didn't want to interfere with that. So I'm mapping LED2 to pin 3, and then I'm also including it in pin mode here. We have to still define it as an output even though we're using it as an analog output. And here I'm reading, we want to read analog 0, that's the first potentiometer, variable resistor VR1. And we're going to still use the serial monitor to print it to look at the value. And then what I do here is I use the analog write. I'm going to write this value, analog value, and write it to the LED 1, which is to that pin. So let's see what happens when we run this code. Whoops, I've got a typo here. Oh, it's LED 2, my bad. And I want to show you as an example here. Notice where it says here line, it shows line 15 on the error. That's one way to kind of identify it, and that's why I sometimes have these line numbers up here. I'm not sure, I think I added a line there, but let's try uploading it again. Ah, got it again. Okay, let's see. There we go. Okay, and if I run the serial monitor again, and I will also turn this guy on. So now I'm going to adjust, you'll notice that the LED 2 is off, but as I adjust this potentiometer here, the value is 55, 100, it gets up to 255, and then it gets dim again. And it ends up doing that a few times, 4 times to be exact. And let me explain what's happening there. So the output, the analog output is scaled from 0 to 255. But the analog input that we read is scaled from 0 to 1023. So what happens is it ends up kind of overlapping. And how we'll fix that is using the map command, and you'll see that in the next section of code here. Okay, so in my code now, I've added a new variable called newval. Kept the setup the same, but what I'm doing here now is using this map function. And what that does is I'm going to map the value that was originally from 0 to 1023 to 0 to 255. It's just basically scaling it. What's important, a couple things that are really important, you can't just use the map command by itself. You have to store that value into a variable. Now what's kind of confusing about that is that you can compile this, for example, and it'll say there's nothing wrong. But it's a little bit misleading. We always have to make sure that we're storing that mapped value into some kind of new variable. So in this line here, we're reading that analog input 0, which is the first variable resistor, potentiometer on the board, and we're scaling it from 0 to 1023 to 0 to 255. Now what I'm going to do here is in the serial monitor now I'm going to print both of these values. It's going to be a little hard to see because it goes really fast. I might slow it down in a second. And then what I'm going to do is take that new value that was mapped and write it to LED2. So let's run the serial monitor here. And as I'm turning this, you're going to see, it's going to be hard to see. Let me do this another way here. Okay, I modified this a little bit where I'm doing serial print of analog value. That's our original value. That should be from 0 to 1023. And then I'm doing a print space, so that doesn't put a line feed or a carriage return, or what you think of as an enter. And then I'm going to print the new value, the scaled value. And I'm going to print that on the same line and then put a carriage return. So when we run this now, let's take a look at what this looks like. If I run the serial monitor now, if I go to 0, the value is 0. As I adjust the potentiometer, I'm scaling this now from 1023 to 255, which is the maximum value of the output for an analog write, in our case with the LED. So let's see what's going on now with the board as I use this. Okay, so at 0, LED is off, and now I can adjust the brightness here slowly, and it increases in brightness all the way to the maximum value. I've taken the value that's being read from the potentiometer, which is in this column, and mapped it to the value on the output, which is in this column. So hopefully that'll help you as you go through these labs to understand how this works a little bit. Feel free to use a serial monitor. We'll spend a little bit more time getting into more depth on that.